Hey everyone, I'm Anish and welcome back to PrepFusion. So today we'll start our lecture 7 of polar plots, right? So until now we have been studying about the frequency response and we have studied about the gain margin, the phase margin, the gain crossover frequency and the phase crossover frequency. So in the previous lecture I stopped in between, right, towards the end to give you few things, like these are few things that I have wrote down after that, right? And this was a table that was required to fill up by you, right? So obviously it's in the note, present in the notes obviously, but I wanted it to be done by yourself. Okay, so yeah, I hope you have done it by yourself. Like we have already found out the values, right? Just you have to put in the values. So what have you noticed here? What thing have you noticed here? The thing that you have noticed here is that if my omega pc, like omega gc is this, omega pc is this, and my gain margin is, let's say, 6 dBs, right? It is in dBs. Gain margin is in dBs and phase margin is in degrees. Okay, phase margin is in degrees. So my gain margin in dBs is like 6 and phase margin in degrees is 9.6, right? So like I can see my system is stable. Now what happens? Like my gain crossover frequency is 2 and phase crossover frequency is also 2, right? Same. And my phase margin is 0, gain margin is 0 dB this times and my phase margin is 0 degrees. So my system is marginally stable. So my system becomes marginally stable if my gain margin and phase margin both are 0, right? And if my gain crossover frequency and phase crossover frequency both are equal. Now what happens, like if my gain crossover frequency is this and phase crossover frequency is this, and what do I see? I see gain margin is negative. So like it has already crossed the one point, critical point. I will show you graphically what does this negative mean, right? What does this negative sign mean? And my phase margin is also minus 9 degrees. Okay, I will show this one also. What does this minus 9 degrees mean? So if my gain margin and phase margin are less than 0, then my system becomes unstable. So this is a very interesting important fact to note here is that if my gain margin and phase margin is positive, okay, then my system will be stable. If my gain margin and phase margin equals to 0, then my system will be marginally stable. And if my gain margin and phase margin is less than 0, then my system will be unstable. But there is a big condition here. These are relative stability parameters. In most cases they will give us the correct answer, but in some cases they may give us wrong answer also. Okay, about this I will come to it in just few minutes, but first understand the relation, all this, right? All these relations, let's just first understand, then I will come to when is this not valid. Okay, sometimes this may not be valid. So what is another thing you notice? That gain margin, phase margin, you notice, that is good. Okay, what is another thing you noticed? That when my system is stable, my gain crossover frequency occurs earlier than my phase crossover frequency. That is, my omega gc is less than my omega pc. Okay, now when my system is marginally stable, then my gain crossover frequency and phase crossover frequency both are equal. And also when my system is unstable, then my gain crossover frequency is more than my phase crossover frequency. Okay, so my gain crossover frequency is more than my phase crossover frequency. So yeah, then my system becomes unstable. So my gain crossover frequency greater than, like, my phase crossover frequency occurs earlier than my gain crossover frequency. So yeah, those things you have to note. So I've written PQ points, right? PQ points I've written. If the polar plot crosses the negative real axis before the critical point, then my system will be stable. What does this mean? So this means this one, right? So my polar plot crosses the negative real axis like before passing the critical point, right? So before passing the critical point, so it crosses the negative real axis like it doesn't, and before passing the critical point, so it doesn't pass the critical point here, it crosses my negative real axis, right? Like before even passing the critical point, so it doesn't pass the critical point, it crosses the real axis before passing the critical point, so then my system will be stable. What does the second point tell? After reading the second point, you will understand it better. If the polar plot of OLTF crosses the negative real axis at the critical point, then the system will be marginally stable. So this is the polar plot of OLTF and it crosses the negative real axis at the critical point itself. What is the critical point? Critical point is minus 1 comma j. So this is very important, right? Critical point, I have written it brackets over here also. It is minus 1 comma j0, right? It is on the minus 1 point. Why is this critical point? I told you, right? When my OLTF is equals to minus 1, then we'll get a crossover frequency, right? We'll get a crossover frequency. So crossover will happen, obviously. Poles will either shift from LHP to RHP or RHP to LHP of the S plane, right? So yeah, it's about the margin stable. Now if the polar plot of OLTF crosses the negative real axis after critical point, then it will be unstable, right? So let's say it crosses my here, right? It crosses my negative real axis. This is my negative real axis, right? It crosses my negative real axis after the critical point. Okay, after the critical point, then my system will be unstable. Okay, then my system will be unstable. What does this mean? This means basically like this is my what phase crossover frequency, and like this has some magnitude of more than 1, right? So here, like as this is constantly decreasing, my omega gc will be somewhere around here, right? So my omega pc is less than my omega gc, right? So my omega pc is less than my omega gc. So from here also you can say that yes, like my system will be unstable. Like what is omega pc? Omega pc is the phase crossover frequency. So at this point we're getting omega pc, right? Omega pc, and let's say at some hypothetical point, right? At some hypothetical point, uh, let's say it is around here, right? We're getting omega gc. So because like this has magnitude more than 1, right? As you can see, this has magnitude something more than 1. Okay, something extra magnitude, I'm not showing it. So I will not show it. Okay, but it has something magnitude extra more than 1. But phase crossover frequency I can understand. Whenever my polar plot cuts the negative real axis, it is known as the phase crossover frequency. So from here I can understand this is omega pc and this is omega gc. So I can see that my omega, which color should I use? Omega pc is less than my omega gc. Okay, this is one point to note here is. And what can I say by here? So let's say like my magnitude will obviously decrease, but here, right? Okay, omega, okay, sorry, one thing, yeah, here, right? Obviously there is a unit circle and it is cutting it at this point. So obviously this is the omega gc. I like forgot to mention this actually. So obviously it is cutting, like this is the this has always distance from the origin 1, right? So at this point my magnitude is 1, so this point, right, will be my omega gc. So hence obviously this is the gain crossover frequency, and here it is crossing the negative real axis. So yeah, that is good. Now let's come to this first one, the stable system. So let me name this as stable. Margin is stable, right? So this is marginally stable. Okay, so like what about stability? So it cuts my unit circle here, right? My omega pc is here. Okay, no, sorry, not here. My omega pc is here, right? So this is my omega pc, right? And here, right, it cuts my like unit circle. So this is my omega gc, right? So this is my omega gc. So yeah, this is my omega gc and this is my omega pc, right? So now basically what can I observe? Like obviously I'm increasing my frequency, right? This is like frequency is increasing, right? Frequency is going from 0 to infinity. Here, right, also frequency is going from 0 to infinity. So this time my omega pc comes earlier than omega gc. Okay, here this time my frequency is increasing from 0 to infinity. My omega gc comes earlier than omega pc. So my omega gc will be less than omega pc, right? So my omega gc will be less than omega pc. So you are seeing the conditions, right? So when my omega gc is less than omega pc, system will be stable. When my omega pc is less than omega gc, system will be unstable. Or when my system, like when my what do you say, when my omega pc and omega gc both are same, right? Here obviously my magnitude is 1 as it is cutting the real it is cutting the unity circle. Also I am crossing the negative real axis also, so at the same time, right? So obviously here, right, omega gc equals to omega pc. Okay, omega gc equals to omega pc. So yeah, this one is about the all the differences between the systems, but this is not always the case. But like when my OLTV is stable, right? When my OLTV is stable, this will be always the case. So that is what I have mentioned in these points. You just read through these points and you will understand exactly what I've shown you graphically, right? That is basically what I've told you, right? Also one more thing is that all this is valid, okay, valid only for negative feedback system, right? All this is valid for negative feedback system, so it is very important to note, right? So yeah, like you just keep in mind, so if they give you some positive feedback, then obviously this all these things won't be valid anymore, right? So like let's go to the last critical like key point. Basically, if system is stable, then my gain margin and phase margin will always be positive. Okay, if system is stable, then my gain margin and phase margin will always go positive. But this is a conditional point, right? Conditional point. Okay, as these, right, these are my phase margin. Okay, these are my what do you say, relative stability parameters. Relative stability parameters. These are my relative stability parameters. So if these are my relative stability parameters, then what will happen? Basically, like if my OLT is stable, then this condition is valid, then this condition is always valid. Always valid. What do you mean by stable? Stable means if like the poles of the OLTF, right, they are always on the left hand side of my S-plane, right? That is for OLTF. Okay, and if my OLTF is not stable, OLTF is not stable, right? Or if my OLTF is a minimum non-minimum phase system, so if my OLTF not stable, then what will happen? Then obviously can't comment, right? Can't comment. Okay, because it may so happen for gain margin positive and negative, my system is stable. It may so happen. Okay, so also we may get multiple gain crossover points and phase crossover points. So for multiple gain crossover points also, like it may so happen you may get multiple gain crossover points, it may so happen, right? So for that also we can't comment, right? Can't comment about stability through relative stability parameters. Okay, comment about okay. So yeah, this one is about this one, as these are through relative stability parameters, we can't comment about those things, right? So yeah, this was about the previous lecture. Now let's go to our current lecture. So in lecture 7, what we'll do, we'll do questions, right? Questions on polar plots. I skipped a few topics, right, intentionally to do it now, because like you wouldn't be able to understand those things in the starting of the chapter, right? So now again, right, what I want you to do is plot again polar plots of OLTF, but this time with a bit of a twist. What is the twist is, this time I have open loop zeros. Earlier I didn't have any open loop zeros, right? Now I have open loop zeros as well. So like take the screenshot or pause the video, try to draw the polar plots of these two, right? Okay, these have open loop zeros. This will be easier for you. Okay, not that difficult, because just you have to consider zeros. But while considering zeros, you have to understand whether you have to consider the effect of poles or zeros initially or towards the ends. Okay, that you have to understand. So what you can do is watch me solve the first question, then you try to solve the second question by yourself. Okay, so let me draw, if you have poles and zeros, like, so let me first draw the pole zero diagram, or let me draw the S plane, right? So let me copy this question. So yeah, this is this one. So now what you can do is, basically we have two poles at s equals to 0, and we have one pole at s equals to -1, okay, and we have a 0 at s equals to -4, and sorry, at s equals to -3 and s equals to -4, also another 0. Okay, now whose effect we have to consider, right, initially or later? Okay, so I will also tell you through, like, I will also explain you through the angle formula also. Like, the magnitude doesn't matter, because magnitude will always reduce. Why? Because the denominator is here, right? Denominator is here, and the order of denominator is more than the order of numerator. So magnitude will always reduce. It will go towards 0 itself, right? So okay, I will explain it here a little. Let's first write the magnitude expression and the angle expression. So what is my g of g omega? So basically it is, right, g omega plus 3 g omega plus 4 this is g omega whole square, and this is g omega plus 1, right? So like, okay, sorry, not the magnitude expression, I'm sorry, this is just the normal, like if I replace s equals to j omega, right? So now let me write the magnitude expression. So this, right, this becomes like minus j square is, like j square is -1, so this is minus omega square, right? Okay, so this is this one. Now like let me write the magnitude expression. Magnitude of, let me write it different pen, that's in white. Omega square plus 9, all of this will be in under root, only omega will be on the outside, right? Omega will be on the outside. Okay, sorry, I missed. Okay, this is omega square actually, sorry, this is omega square, so omega square will be outside, right? So like, okay, I will explain you a bit more. Let me first do it. Omega square plus 4, what is this? So this is omega square to the square plus 0, okay, because imaginary component is not present, right? This is minus omega square plus 0. Here, right, and overall it is under a root. Okay, like I could have written this directly also, but just to, like, few people may not understand that how does omega square come outside the root. Okay, for those I'm doing this. So this is 1 by omega square here, okay, and this is omega square plus 9, omega square plus 4, and this is omega square plus 1. Okay, so yeah, this one, right? So now, like, I got the magnitude function, okay, magnitude expression. What can I say about the magnitude expression? I can say that this is always a reducing, like a reducing function, right? Why? Because like my order of the denominator will be more than order of numerator, so there won't be any questions, right, about the magnitude. Magnitude is not debatable at all. The phase angle always is debatable. There is where the problem will come, right, to calculate. Okay, magnitude is always easier to calculate. So, and no one cares of magnitude. Okay, so what I can write here is that uh, magnitude is a decreasing function. Okay, as order of denominator, or I can say less than order of denominator. Okay, there will always be no debate, because this is always be a proper transfer function for us to get a realizable system. Our transfer function will always be proper, that is number of poles will always be greater than or equals to number of zeros, right? Okay, so for proper transfer function, this condition will always be followed, that is number of greater than equals to number of okay. So yeah, this is this one. So now right now let's go for the angle condition. Let's find the angle expression. So this is the magnitude, let's find the angle. Angle of g omega into h of g omega, which is equals to simply, okay, very important note here is that what does this minus sign represent? Okay, minus sign represents minus 180 degrees, right? So what does our zeros provide the angles? Okay, zeros, what does zeros give angle? So zeros, right, like as I have two zeros from here, like two poles, I can on the like origin, I can simply say it is minus 180 degrees. That also I can simply say, or you can understand from here also, like it will provide, like as I have two poles at the origin, it will provide minus 180 degrees. So that effect is gone. I got a type, right? Type is 2 this time. Okay, to type 2, I am getting minus 180 degrees. Now what angle is my zeros contributing? So angle due to zeros is this one first, omega by 3, tan inverse omega by 3, and due to this one is tan inverse omega by 4. Okay, so yeah, this is this one. So now what angles are my poles contributing? Due to poles, some negative sign will come, right, as they are in the denominator. Now what angle are my poles contributing? Only I have like one pole, like which is not at the origin. This is like at s equals to minus 1, right? So this will be tan inverse omega by 1, which is omega itself. Okay, so what is this now? What is this now? So basically, right, what I can say is, like how will I write the angle condition? Because earlier what used to happen was that, like I only had poles, so only angle was reducing. So I was moving in the clockwise direction, if you remember correctly. Why clockwise? Because this was negative. So as this was negative, due to this I didn't write told you about the clockwise anti-clockwise due to confusion. Okay, now I will tell you a bit. Okay, as this is negative, right, this is negative. Okay, so I can remove the bracket. Okay, no need to use the bracket. As this is negative, so due to this negative I will have clockwise movement, right? I will have clockwise movement. Okay, as this is negative I will have clockwise movement. Now if this is positive, like if my angle is, why negative clockwise, like you I would remember, right, if my angle is negative, okay, I have an angle, if my angle is negative, so I'll move in this direction, right, not in this direction. If angle is positive, I will move in anti-clockwise direction. If my angle is negative, I will move in clockwise direction. So I have, like these things are basic, right? So here, right, I am seeing I am getting some clockwise movement as well, right? Sorry, some anti-clockwise movement as well. Okay, let me use some different color. So I'm getting both clockwise and anti-clockwise movement. So here that is the issue. So how can I say that now at this frequency it will go in the clockwise direction or in the anti-clockwise direction? So if I'm at this point, right, I'm confused in which side to move, whether to move in the anti-clockwise direction or in the clockwise direction. So this is a confusion, right? So yeah, this is this one. Now how to remove that confusion? To remove that confusion, what we can do is simply uh, like simply come over here in the pole zero diagram and specify a very important point. What is the important point? The important point is that the effect of the pole slash zero, which is more nearer to the origin, will be considered for smaller values of omega. Okay, so like obviously for smaller values of omega, so this is present, right? So this effect will be dominated, right? This effect, this pole will be dominated. So let me write this down. Effect effect of poles slash zeros are more nearer to the origin will dominate. Okay, will dominate for smaller for smaller values of omega. So those effect, right, they will dominate for smaller values of omega. Okay, so like why is this the case? Okay, so here, right, I can see like this for angle, this for angle. Okay, for angle of g of g omega into h of g omega, right? This for that. Okay, so like why is this the case? Let's prove it, right? So here this is my angle expression. Okay, this is my angle expression. So what you can see is, if my omega is very low, right, omega is very low, okay, then my omega 3 will be even lower, and my omega by 4, sorry, omega by 3 will be even lower, and omega by 4 also will be even lower, right? So what is like, okay, let me write here. You calculate in your calculator, right? What you do, you put omega equals to 0.1, right? If you put omega equals to 0.1, what you can see is basically that this will be like tan inverse 0.033, right? Point 0033, sorry, 0.0333, and this is 0.025, and you calculate those angles, those will be almost near about to 0. Okay, almost nearly they will be towards 0. Okay, so let me check if it is recording or not. I'm always fearful. Yeah, it is recording, that is fine. So those will be almost near towards 0 itself, right? Almost near towards 0. Okay, if they are near towards 0, and only this effect will come, like this will be some value, but these will be so less, right? I can consider this as zeros, so I can simply ignore this, right? Ignore this for lower values of omega, right? So this will be only considered. Okay, that's why like this is more nearer to the origin, right? This is more near to the origin, that's why this is considered. Okay, that's why this is considered, and all these are ignored. Okay, so yeah, I hope you basically get the point, like why do we use. So let me write here. I will copy this expression. This will dominate, right? Okay, this I can ignore. Okay, this I can ignore. this is a calculum, right? Like you just put the value, right, and you check, right, you check, so you will see, right? So yeah, that was the case. Now let's write down a table, right, a table of values, and put the values over here. So at omega equals to 0, what is happening? At omega equals to 0, my magnitude, right, if you put omega equals to 0 here, magnitude becomes infinity, right? Magnitude becomes infinity, so that is okay. Okay, and what about my angle? So angle is minus 180, because if I put omega equals to 0 over here, like all these are vanished, right? These are vanished, and only I am remained with minus 180, right? So I'm remained with minus 180. Now you might ask, like, how did I get this under root 5 point? I'll tell you, right? And why is this under root 5 point here? That is also important. I will also explain. So what about this now? Now which side I will go? Like this is minus 180 point, and I am telling you for lower values of omega, this one will dominate. So my pole is dominating, right? And so my negative angle is dominating. Hence, what can I say? My angle is negative. What can I say? That my clockwise rotation, okay, I will have clockwise rotation, okay, due to this negative angle. As this is dominating, right, I will have clockwise rotation. So initially what will happen, from minus 180 degrees, right, so minus 180 is here, so it will rotate in the clockwise direction. So it will rotate somewhere here, right, to rotate somewhere here. So initially what is happening, it is starting from minus 180, then it is going towards the clockwise direction. So the angle will increase towards the negative direction, right, increase towards negative direction. Okay, then after a certain point, what will happen? Let's see that, right? So after a certain point, again, right, effect of these one will come. Okay, effects of these one will come, like effects of zeros will come. So effect of positive angle will come, effect of clockwise anti-clockwise rotation will come, right? Okay, so what will happen is that slowly, again, right, after a certain stage, my angle will again increase, right, again increase. Okay, and slowly what will happen, the effect of this one will be cancelled by the effect of this one, because for higher values of omega, okay, my omega and omega 4 by 4 will be like tan inverse omega and tan inverse omega by 4 will almost be equal. So let me write here, okay, for higher values of omega, tan inverse omega will almost be equal to tan inverse omega base, right? So they are almost equal. So like if you put tan inverse 100 or tan inverse like 1000, whatever you put, right, like sorry, you put omega is 1000 and check, right, you will see they are almost equal. Okay, so yeah, for higher values they are almost equal. So like this angle and this angle will almost be equal, so they will be cancelled, right, and I will be only remain with this one. So only I will go in the again in the anti-clockwise direction. Okay, or like don't get confused by this clockwise or anti-clockwise, right? Okay, I don't want to confuse with this clockwise anti-clockwise direction. I want to just say that my angle will reduce, so that is fine, that angle will reduce. So as this negative sign, angle will reduce, else you will get confused with clockwise and anti-clockwise direction. Angle will, I don't want to confuse you, right, reduce. So I don't want to like okay. So yeah, and here, right, now this angle will increase. So what I can say is, let's say I will only be left with this one. Okay, this one will get cancelled. Okay, like let's say they are almost equal to 90, so the effect of those one will be cancelled. So my like dominance, right, dominance will go from here, right, like this. I will go from here. Okay, like you can understand, right? First, whose effect I considered? Whose effect did I consider first? I considered the poles at the origin, minus 180. Okay, that's why at omega equals 0, minus 180 is there. Then whose effect I considered? this pole, right, which is at s equals to -1, then whose effect I will consider? It is 0, right? So then 0 is coming, so what will happen? My angle will increase, okay? Angle will increase. Then again another 0 is coming, my angle will further increase, right? So this is a sequence of like operation what will happen, right, in the polar plot basically. Okay, so this is a shortcut. Like this also you can remember. So here, due to this my angle is -180 degrees. Due to this my angle will reduce, right? Angle due to this my angle will increase. And due to this my angle will further increase. Okay, like this better. Okay, so yeah, this is this is shortcut you can follow, right? So what will happen, like without even writing the values, I can say that my angle will again start increasing and it will further increase. It will not decrease anymore, so it will keep on increasing, and my magnitude also is decreasing, right? So what will happen is it will keep on increasing, and then again it will cross this negative real axis. Okay, then my magnitude is reducing and it will come to origin, right? But you might ask, sir, but it can cross this -90 also. For that obviously we'll need this table. Okay, and like why it will not cross -90? It will be just touch at -90. Why? Because at omega goes to infinity, what is happening? This, like this is getting 90 and this is -90, so -180 plus 90 cancelling out, and I am only remained with -90. So at omega goes to infinity, at max my angle can go to -90, and it can't go above that -90, right? It can't go above that -90. So that's why my polar part will look something like this, right? Okay, so this is this one. Okay, so in this region, right, in this region, what I can say, like I'm just explaining the first one in depth, next one you have to solve it for yourself. So in this region, what I can say, my pole is dominant. Okay, and in this region, like since when the angle keeps on increasing, effect of 0 dominant, right? Effect of pole okay, effect of 0. Okay, so yeah, that is the polar plot for this one, but I have skipped a few things. That is basically the table of values. So first, like what is at omega equals to 1? So I've written down the magnitude values here, right? So at omega equals to 1, if you put like omega 1 there, what you will get is like your magnitude value will be 9.22, and your angle, right, and if you check, your angle will be minus 192.53. Like you check it for yourself, there may be some calculation errors. So like as I told you, right, with intuition, as I told you, right, the angle will reduce further, and it is proving, like I'm getting the angle as minus 182, so it is reducing from minus 180 to minus 182. So again, if I increase it to under root 5, right, if I increase it to under root 5, I will get 1.4, magnitude will be 1.4, right, and my angle will be exactly equals to minus 180 degrees. Now you might say, sir, how did you find this omega equals to under root 5, right? So like this may come in exam. Okay, how to find this, how to find like the phase crossover frequency, right? So this time, right, I have two phase crossover frequencies. Okay, so here, right, as I told you, so if I have multiple gain crossover slash phase crossover frequency, then also it is unambiguous to tell out the stability. Okay, gain or phase crossover frequency. Phase. Then also it is difficult for me to tell about the stability of the system. So here, right, what I can see, it is crossing the minus 180 point two times. One is at omega goes to 0, another one is at omega goes to minus 180. So it is difficult for us to comment about the stability, right? Okay, so yeah, this is this one. Now at omega goes to infinity, what is happening? My magnitude is going to 0 itself, right? Omega goes to infinity, obviously magnitude will go to 0, and obviously I told you, right, it like the maximum phase angle can be minus 90. So like I have just wanted to show you, like it is going to minus 182, and it is crossing the minus 180, 180 like the negative wheel axis again, right? So like then, right, so how did I find this omega value? So how to find this like negative real axis point? So how to find minus 180 degree or find omega when polar plot crosses negative totally real axis. So what you can do, you can use the tan inverse formula basically. So you want to find minus 180, right, when my angle is like minus 180 obviously. So you just copy this angle formula. Okay, copy this angle formula and put minus 1 over here and then simplify. You put angle of j omega equals to minus 180 itself, right? So you put here minus 180. So like a beautiful thing is happening, that these is getting cancelled out, right? This is getting cancelled out. Okay, so this and this are getting cancelled out. So this is this and this, and this is tan inverse omega. So sorry, where did I go? Sorry. So this is tan inverse omega equals to this angle. So like this, right, this I can convert into simple like a single tan inverse term. How? Tan inverse a plus b is tan inverse a plus b divided by, sorry, tan inverse a plus tan inverse b is tan inverse a plus b divided by 1 minus a into b. Okay, so I hope you know that simple inverse trigonometry formula, right? So it is tan inverse omega by 3 plus omega by 4 into 1 minus omega square by 12, right? So 1 minus omega square by 12. So yeah, now this and this has to be equal. Okay, this and this has to be equal. So what we can do, like obviously like both are inside and inverse, so inside terms also should be equal. So what I can write here is my omega equals to like 7 omega by 12, right, into 1 minus omega square by 12. So this omega gets cancelled, right? Omega gets cancelled. So I am left with 1 minus omega square by 12 equals to 7 by 12 itself. So what I can write, 5 by 12 equals to omega square by 12. So omega square equals to 5 and omega equals to under root 5, because negative solution I will ignore obviously. So omega equals to under root 5 radians per second, right? Omega equals to under 5 radians per second. So this is how I found the point where my polar plot causes the minus 180 degree angle, right? So this is where my polar plot causes the minus 180 degree angle. Okay, so this is how you can find, right? Omega equals to Okay, so yeah, this is like a one trick to how to find. So now what you should do is you solve the next question by yourself, right? So this is the next question. Now you take into consideration whose effect will come like earlier and whose effect will come later. Okay, and you try to solve it by yourself. This is just the inverse of this one. Okay, just I added another like type of the system, right? So type becomes 3 this time. So I will solve this faster. I'll solve this faster. So which question number is this? This is 20, I think. This one was 19. This is 20. So again, right, I will draw the pole 0 diagram. This time the things have changed a bit. Again, I have I will draw this later. Sigma G omega. I have 3 poles at the origin, right? And this is -1, this is -2, and this is -3. Sorry, this is minus -4, right? So this is this one. 3 poles at the origin. So like what I can say, the like what is the priority this time? So the effect of obviously the 3 poles at the origin will come first. Then what will happen? Then the effect of 0 will come first. Then the effects of poles will come. So what will happen? Initially, obviously what will my angle? Initially my angle will be -270, or I can say +90. Okay, +90. Then what will happen? Then due to this 0, my angle will increase. Okay. Then due to these poles, my angle will reduce. So whether this will cross the the plus 180 like the negative real axis or not, that will depend, right? That will depend. So yeah, let's first do it. Okay, let's first do it. So like what I can say is space, let me make another space. So again, right, put s equals to j omega and like figure out things. So if I put s equals to j omega, g of j omega into h of j omega is equals to j omega plus 1 divided by like j omega whole cube, which is minus j omega cube, and j omega plus 3 into j omega plus 4. Okay, so this is this one, right? This is this one. So now let's write the angle magnitude function and the angle function. Okay, so like I will write it in like single under root itself. So this will be omega square plus 9 sorry, will this work? Okay, this will work actually. That is interesting. And obviously like this omega cube will come outside. I will not explain this again, right? Omega cube will come outside. Now let's write the angle, right? So what is my angle? Angle is basically like due to this like type, like this poles at the origin, my angle will be -270, or I can write as plus 90, right? So I will write directly here plus 90 degrees. then what is happening? Then basically due to this, right, due to this one 0, my angle is tan inverse omega, and now due to these poles, what is happening? These, right, like first is tan inverse like negative, then tan inverse omega by 3 and plus tan inverse, like these are positive, these are in the first quadrant itself, tan inverse omega by 4 itself. Okay, so yeah, now if I expand this, right, if I expand this 90 minus tan inverse omega by 3 minus tan inverse okay, so yeah, this is this one. So now basically whose effect will come first? The effect of 0 will come first this time, right? So effect of 0 will come first. So my angle will increase in the positive direction, right? As my angle is increasing in the positive direction, so I will start from somewhere on the left of my 90 degrees, right? So like as my angle is positive, right? So like initially, like it is 90 plus some angle, these are ignored, right? So 90 plus some angle, so like it is plus, and 90 is also plus, right? So it's in the anti-clockwise, it is 90 here and plus some angle, because plus is there, so I'll move in the anti-clockwise direction. So I will start from somewhere around here. Okay, obviously here I'm not seeing the infinity, okay, it is on the 90 degree axis itself, but just after that, some angle is getting added, so I am starting from somewhere here. Okay, then slowly what will happen? Slowly the effect of like 0 is fine, like my angle is increasing, that is good, right? My angle is increasing, that is good. Then suddenly the effect of poles come, right? The effect of poles come. So if the effect of poles come, what will happen? My angle will reduce, and my angle will further reduce, because I have two poles, right? So it will further reduce, right? Okay, let me like, it will further reduce, and then obviously my magnitude is obviously reducing, right? It's a reducing or like decreasing function, so it is obviously reducing, and it is ending at the origin. It is ending at the origin. Okay, so yeah, this is what basically is happening without even like writing the table, right? I can predict what is happening, with the intuition without even writing the table. Obviously I will write the table, from there also you can understand it, but without writing the table also you can predict the intuition here. Okay, so now what is the case basically? What is the thing basically? So we are crossing it this at this minus 90 degree, right? And why are we finishing? So if you check, right, so at infinity, like this and this is getting cancelled, because 90 minus 90 plus 90 minus 90 getting cancelled, and this is also 90 and this is also 90, so I'm going to 0 degree angle, so I'm like my angle is going to 0, so that's why it is coming like this, right? Going towards the 0 real axis. Okay, ending towards the real axis. Okay, so I hope you understand. So now let's obviously write the values, right? Write the table, complete the table basically. So at 0 obviously my magnitude will be infinity. At 0 what is my angle? Like I'm taking the effect of poles at the origin, so basically we have three poles at the origin, which is minus 270 degrees, which is also plus 90 degrees, right? So it is plus 90 degrees. Now what is happening at omega equals to 1? So if I check for omega equals to 1, right, what is happening? So omega equals to 1, this is omega equals to 1, this is under root 2, this is 10, this is 17, and this is point, this is 1. Okay, yeah, under root 2, 10, 17. So like I'm getting somewhere around 0.1. I'll just check once, right? I'll just check once with my calculator. So what am I getting? Let me just wait 1 second. I'll just check. So this is 2 divided by 10 divided by 17 under root. Okay, yeah, this is almost 0.1 itself, right? So I was just getting confused. How can it be 0.1? So yeah, this is 0.1 itself. right? And what is my angle? So angle I've already calculated, I will not calculate. Okay, so if you check, right, you will check something like it is something more than 90 degrees. Okay, 112. So obviously it will be somewhere around here, right? More than 90. Okay, and this is in the plus 90. Okay, plus 112. This is not minus 112. So minus 112 would have been somewhere around here. Okay, don't get confused by that. This is plus 112. So just be very careful of the signs of the angles, right? So if it is plus 112, so I'm around here. I'm around here. Okay, so yeah, then it will cross. Then it will cross, right? And then obviously, like, why it will cross? This is the crossover like point, right? At minus 90. Again, right, you apply the same formula, you put angle equals to like not minus, sorry, plus 90, and again, right, you will get the same equation itself, right? And from there you will get omega equals to under root 5. Okay, so at omega equals to under root 5, what is my magnitude? Magnitude is 0.012, already written it down. And like angle is 90 degrees. If we check, obviously you put angle equals to 90, and for that you get omega equals to under root 5. Obviously if you put omega equals to under root 5, you will get angle 90. And again, right, omega goes to infinity, my magnitude goes to 0, and my angle this time also goes to 0, because it is reducing now. It is reducing, right? So here what I can say, what I can see, it is increasing, right? I can say increasing, and from here to here, what I can say, this is reducing, right? Reducing, like here also I can say, okay, in this table also, like from here to here it is reducing. Reducing means effect of pole, right? Reducing means effect of poles, and from here to here it is increasing. So here effect zero. Okay, effect of 0. So this is effect of pole and effect of zeros. Okay, if it is reducing, it will be due to poles, and if it is increasing, it is due to zeros. So yeah, this is about this one, and I have already drawn it down with intuition itself. So you can see that it is crossing at my 90 degree, right? That is the proof. It is crossing again at 90. Initially the angle is increasing, and then again it is crossing at 90. So yeah, this one was it for like polar plot for uh, with open loop zeros, right? Now I like this already got extended too much. So what I will do is like give you homeworks of these two questions, right? This time obviously I have zeros also, and also I have poles on the right hand plane of my S plane, right? So you try to draw the polar plot, and then in the next lecture I will do this and also few other questions. Okay, so yeah, I will see you in the next lecture. Thank you for watching.